cam worm, if you will, after I cut it, and you kind of look at the way this half-inch dowel pin fits in here. See, it's following this center line radius out here somewhere. Alright, here we are looking in the CAM software, and I couldn't figure out how to model this in a solid model for some reason, but I was able to model the curves. So here's the outer curve. This is the center line of the I don't know what you call it, thread or groove, if you will, and this is the bottom of the center line. So I was able to model those, and then I could create a ruled feature, which is what you're seeing here, to define the tool path. And what's also necessary is something to drive the tool path, because in a spree you kind of need a solid model or surfaces, if you will, to drive the tool path down to, because you can't make a feature. In order to make a feature, a freeform feature, which is what is necessary to do a path like this, you have to have a solid model. And so that's my solid model of the bottom. If I select the bottom curve, you can see it's the bottom of the thread, if you will, or groove in the, I don't know what you call this, a worm. So I needed those things to define this tool path right here for the end mill. And this is just very simple. I was just trying to go down the center line of it to see if I could actually make the machine do a shape like this. So if we watch the, if we go over here to the simulation, let's just watch the simulation. This is where it starts, like you saw it in the video, or you'll see it in the video, I should say. And this is the motion of the machine. Now it's pretty important to have a simulation of this, as you can see, because I didn't bring the tailstock forward, but you can see how close it gets to the actual cabinet of the machine. If this wasn't sticking out this far, you would collide with things. And the tool has to be this long, unfortunately, on this machine, because you'll hit the chuck here or the tailstock on the other side unless you have that long tool. That's kind of the situation with these mill turn machines, because their spindle faces are kind of big in diameter. So basically this is following, up here there's a center to this radius, and it's making the center line of the tool pass through the center of that radius in order to create this shape. Like I said, I couldn't figure out how to model this in my CAD software, because if I could have done that, it would have been a little easier to deal with on the programming side of it. But this worked okay, and I think it's pretty accurate. Although I think I would have to, if I was really going to make a roller cam, and this would be the worm to drive the roller cam, then I would really need to grind this. So I'd have to make some kind of a special, I don't know, fixture or device or something to actually grind the shape. And that would be a kind of a little bit tricky to do. And I think I'd also split it down the middle here so that I could preload the bearings, the cam rollers on it, and make it with zero backlash, if I could do that. Now the cam roller is just a disc with some cam follower things that I could buy them from Master Car. And that's pretty simple. But this is a complex shape that's kind of hard to even visualize. If you see, it's got kind of undercuts following the radius of the disc, if you will, and the cam rollers that go through this. So to actually assemble this thing, if you made it, you can't just stick the disc in from the side, kind of like you could engage a worm gear. You couldn't do it because the rollers wouldn't go in. You have to put each roller on the disc one at a time and rotate it around through the worm. This is the way it envelops the rollers, if you will, on this. So that's the CAM program. And we can watch it do it one more time. I'll speed up the simulation a little bit here. And like I was saying when I filmed this, on these kind of tool paths, it's kind of better to make rap or high feed rate moves for these transitional moves between passes than it is to use rapid movements. You can do both, but I have found that it actually goes slower with rapid movements for some reason. It does better if you just put high feed rates. I wasn't going real fast in the actual doing of this. I think about 300 inches a minute on these transitional moves. I was being very conservative with this whole thing because I was a little bit nervous on doing this because you can see the amount of movement there is of the z-axis of the machine in tipping the spindle, and it comes very close to the cabinet over here and the tailstock. If I had the tailstock forward in this simulation, I just didn't bother with that. Alright, here's in the CAD software, and here's the model of the cam roller drive. Now, like I said, I couldn't figure out how to actually model this thing and cut away that roller. I've figured out how to draw the curves, and here's the curves. That's the one and the other one that I imported into the CAM software, but this this is kind of a hard thing to model for some reason. I couldn't figure out how to do it. You know, the curves, I can have the curves all right, and it took me a little bit of time to figure out how to actually program that, because if I could model this thing as a real solid with the you know, the worm cut into the blank, then it would be a little easier to program. But this is the idea. See, these cam rollers, these are actually standard parts. I just downloaded the model from the master car. The rollers, these are 1/2-inch diameter rollers, and there's 24 of them, so this would be a 24-to-1 reduction. And this is most ideal if you're going to use this for like a rotary axis on a CNC machine or something like that, because you can preload this. If I made this worm, if you will, in 2 pieces, and then I could adjust it together, you know, put nuts or something on each end of it and put shims in the middle and adjust the preload on the sides of the cam rollers. You really can't make the cam roller fit perfectly in the groove, because it has to rotate, and it has to contact one side of the groove or the other. So you would almost have to preload. I mean, maybe you could make them tapered. That might be a way to do it, and then adjust the distance between the centers of rotation of the disc and the worm, and that possibly, but I don't think that would really work, because these kind of change locations when you change the center distance. So the center distance on my just idea here, I think it was it's 4 inches. So when you see the machining in the machine, it has to keep the tool center line going through the center line of this rotation of the cam roller itself, the roller gear, if you will, and that's what it's doing in the CAM program based on these curves and the rule surface that I generated in the CAM program. So this is the model in CAD, and the way I generated those curves was actually laying out these sections of where the rollers would be around the worm, if you will, and then drawing spline curves to each one of these intersection points. And then I imported those two curves into the CAM software and modeled the shape of the bottom, if you will, the bottom radius of the groove, which you'll see in the CAM software part of this, when I show that, and you generate the tool path based on the ruled surface that I generated with the two curves and the bottom profile of the groove. So that's the model in the CAD software, and I sort of had an idea of wanting to make one of these, possibly build a small CNC machine that's similar, to this Integrex in the way it moves, and used one of these for the C-axis and for the B-axis. And that way you can get high-speed movements with hopefully precision locations, depending on how precise you make this this worm in relation to the spacing of these rollers here. But you can see that you can't just stick the worm onto this roller gear. You would never be able to assemble it that way. You have to put each roller in and rotate it, put the next one, rotate it, and rotate it until you got it all the rollers on the roller gear, I'll call it. cam worm, if you will, after I cut it, and you kind of look at the way this half-inch dowel pin fits in here. See, it's following this center line radius out here somewhere. Normally, like I said, the finish isn't good enough just to use it like this, but maybe I could improve that by taking some finish cuts, you know, like cutting it with a smaller diameter end mill to rough it out, and then come back and offset the tool path on each side to cut finish cuts, and maybe that could improve it. But I think in reality it would have to be it would really probably need to be ground to make it really precise, and that I don't think, I mean, I'm not sure, but I don't know that the machine like this machine with the tool that far away from the center of rotation and everything could probably do that precise enough to get some real accurate positioning on the rotary axis. So you probably have to make a special fixture that held this worm, and then it had a grinder that could rotate at the radius with a small diameter grinding wheel and grind that, maybe. I don't know. That might be what you'd have to do. I'm not sure. That might have to be. Also, like I said in the video, I would split it down the middle here so you could preload these things together, so the cam rollers would actually be hitting on this side, and then when they come through they'll be hitting on this side as they rotate through the worm.